Hi guys, let us continue our topic, the Archimedes inventions. His next invention is odometer. Archimedes has also been credited with the first idea for an odometer, or at least a mechanical method of keeping track of distance traveled. The Roman engineer Marcus Polio wrote an account of this idea, which he credited to Archimedes. The odometer operated on the idea that every time a wheel goes around, it travels its circumference. The odometer may have used a large wheel of known circumference and a series of gears. The theory is that a gear on the drive shaft had only one tooth, and a gear holding a box of pebbles had additional teeth. The pebble gear moves one notch whenever the chariot wheel goes completely around. After the wheel had gone enough revolutions to equal 1 mile, the pebble gear would have moved a hole leading from the pebble box lined up with a hole underneath the gear, and a pebble dropped into a bucket. Counting the pebbles could tell you how many miles had been traveled. Each dropped marble represents 1 mile traveled. The same engineer, Marcus Polio, who accounted Archimedes' Eureka movement, also reported Archimedes to have mounted a large wheel of known circumference in a small frame, in much the same fashion as the wheel is mounted on a wheelbarrow. When it was pushed along the ground by hand, it automatically dropped a pebble into a container at each revolution, giving a measure of the distance traveled. It was in effect the first odometer. This mechanism is said to have been invented by Archimedes during the First Punic War. Now about his maths work. The geometry of spheres and cylinders, the measurement of the circle. Archimedes' other mathematical achievements include deriving an approximation of pi, defining and investigating the Archimedean spiral, and devising a system using exponentiation for expressing very large numbers. He was also one of the first to apply mathematics to physical phenomena, working on statics and hydrostatics. Archimedes' achievements in this area include a proof of the law of the lever, the widespread use of the concept of the center of gravity. Archimedes is widely regarded as one of the greatest mathematicians in history. His contribution contain various branches of mathematics, including geometry, calculus, and number theory. He developed innovative methods and problem-solving techniques that laid the foundation for many mathematical principles still used today. For instance, he discovered the method of exhaustion, which allowed him to approximate the area and volume of the irregular shapes by dividing them into an infinite number of smaller, manageable parts of integral calculus. By continuously refining the approximation through the subdivision of shapes, Archimedes was able to obtain accurate results. Archimedes made significant contributions to the understanding of the mathematical constant pi. Pi represents the ratio of a circle's circumference to its diameter and is approximately equal to 3.14159. While Archimedes did not provide an exact value of pi, he was able to approximate it with a great accuracy using a method of the polygons. Roman historian Plutarch wrote that Archimedes did not hold his mechanical inventions in a high regard. Instead, he was much prouder of his proofs and theories in physics and mathematics. The great engineer is credited with proving that the area of a circle is equal to pi multiplied by the square of the circle's radius, that is pi into r square. He also provides that the area enclosed by a parabola and a straight line is 4 by 3 into the area of the corresponding inscribed triangle. According to Plutarch, the famous Greek biographer, he wrote in his theoretical explorations of mathematics and physics, Archimedes is credited for 9 extant theses, among which the two are volume of sphere and cylinder. In this fantastic work, Archimedes determined the surface area of the sphere of radius r is 4 times that of the greatest circle. In modern notation, surface area A is equal to 4 pi r square, and that the volume of the sphere is 2/3 that of the cylinder in which it is inscribed. Volume of sphere V is equal to 4 by 3 into pi r cube. Archimedes was so proud of this achievement that he left instructions for his tomb to be inscribed with a sphere inscribed in a cylinder, the measurement of the circle. Determining the area of a circle was once considered a great mathematical challenge. Archimedes found a method called squaring the circle. He first created a circle inscribed inside of the circle. Inscribed means that it exactly fits inside with its vertices just touching the edge of the circle. Since he knew the area of the square is product of the two sides, it was clear that the area of the circle is bigger than the area of that inscribed square. He then fitted a polygon with 6 sides instead of 4 within the circle and computed its area. He gradually worked on more complex polygons to get even closer to the circle's true area. Eventually, Archimedes got really good at this and discovered pi, the ratio of the circumference to the diameter of the circle. His calculations use an astonishing 96-sided polygon. In other words, he calculated an estimate that was equal to pi up to 2 digits, 3.14. As you can probably say from this brief list, though the inventor had a significant hand in working on early physics and mathematics, mechanical design, and even art, he was the most extraordinary polymath and rightfully deserves his place in the history books. Now last, the death. Archimedes' works were lost for centuries after his death, but many of his works were rediscovered. Archimedes' works were highly regarded in his time, but many of them were lost by centuries after his death. It was not until the Renaissance period that some of his writings were rediscovered and translated from Greek into Latin. These rediscovered works include mathematics, physics, and engineering. One of the Archimedes' most famous surviving works is On the Sphere and Cylinder, in which he explored the properties of spheres and cylinders and calculated their volumes and surface areas. Another significant surviving work is The Method of Exhaustion and its application to calculate areas and volumes. We know more about the circumstances of his death. In about 212 BC, during the Second Punic War, when Roman forces under General Marcus captured the city of the Syracuse after a 2-year-long siege. Actually, Archimedes had played an important role in the defense of Syracuse against the Roman siege by constructing war machines. According to Plutarch, Archimedes was contemplating a mathematical diagram when the city was captured. A Roman soldier commanded him to come and meet General Marcellus, but he declined, saying that he had to finish working on the problem. The famous reply was, "Don't disturb my circles." The soldier was angered and killed Archimedes with his sword. According to one story, Archimedes was carrying mathematical instruments and was killed because the soldiers thought they were valuable atoms. General Marcellus was angered by the death of Archimedes, as he considered him a valuable scientific asset and had ordered that he should not be harmed. However, during the choice of the siege, a Roman soldier encountered Archimedes when he was busy in mathematical diagrams and equations. Ignorant of his identity, the soldier became impatient and killed Archimedes. The death of Archimedes marked the end of era of ancient Greek science and mathematics. It was a great loss to the intellectual world, as he left behind a legacy of extraordinary achievements, continuing to influence and inspire scientists, mathematicians, and engineers even today. Cicero describes when he visited Archimedes' tomb, which was surmounted by a sphere and a cylinder, that Archimedes requested be placed there to represent his mathematical discoveries. Archimedes the Great, I bow and salute him thousands of times. Thank God. He donated a great gift to all mankind. Be prepared for both power and courage to do anything. Get energy in your body and mind. Please like it, share it, and subscribe it. Thanks for watching.